Example 9. Find the number of permutations of the letters of the word Allahabad. A, L, L, A, H, A, B, A, D. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 alphabets, out of which we have 4 A's, 2 L's we have, and all other letters are different. Find the number of permutations of the letters of the word. So we have to make use of all the 9 letters. So number of ways is equal to, we have identical objects here, identical alphabets here. So we have to use 9 factorial divided by 4 factorial into 2 factorial. We are using n factorial divided by p1 factorial into p2 factorial formula. Let us simplify this. 4 factorial could be cancelled. So we get 5, 6, 7, 8 and 9. Divided by 2 factorial is 2. (30 into 7 into 36). (30 times 252), which is 7560. Example 10. How many 4-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed? So the first condition given is we have to form a 4-digit number, and the second condition given is using the digits 1 to 9. 1 to 9 we have 9 digits. If repetition of digits is not allowed, we may use fundamental principle of counting. So ones place digit can be filled up in 9 ways, then 8 ways, 7 and 6. So the answer will be 6 into 7 into 8 into 9. Or we may use the permutation formula. We have 9 digits given, out of which we have to select 4 digits and arrange them. So 9p4. So number of 4-digit numbers is equal to 9p4, which is 9 factorial divided by 9 minus 4, 5 factorial. Cancel 5 factorial, we get 6, 7, 8 and 9. The product is 3024. Example 11. How many numbers lying between 100 and 1000 can be formed with the digits 0, 1, 2, 3, 4, 5 if the repetition of the digits is not allowed? So the first condition given here is the numbers are lying between 100 and 1000. Between 100 and 1000 means 101 to 999. That means all these numbers are 3-digit numbers. So instead of giving directly that you have to form a 3-digit number, it is given that the number should be between 100 and 1000. And the second condition given is we can make use of these digits 0, 1, 2, 3, 4 and 5. So totally 6 digits are given. If the repetition of the digits not allowed, So these are the three conditions given. We have to form a 3-digit number. We have a special condition for this particular position. I cannot use 0 in this position. If I use 0 here and 3 and 1 here, say, so the number becomes a 2-digit number. It won't be a 3-digit number. Therefore, I cannot use 0 in the hundreds place. So that position has a certain condition. 0 cannot be used. So fill up that position first. So this can be filled up in 5 ways because 0 cannot be used. 1, 2, 3, 4, 5. Only 5 choices are there for this position. Then for the rest of the 2 positions, I have remaining 5 digits, out of which I have to select 2 and arrange in 5p2 ways. So number of ways is equal to, or you may use fundamental principle of counting, 5 times 5p2. 0 cannot be used in hundreds place. Which is equal to 5 times 5 factorial divided by 5 minus 2, which is 3 factorial. Cancel 3 factorial, 4 and 5. The answer is 100. Example 12. Find the value of n such that, let us do the first subdivision, np5 equal to 42 times np3 and n should be greater than 4. Let us use npr formula, which is n factorial divided by n minus r factorial. Let us use this formula, n factorial by n minus 5 factorial equal to 42 times n factorial divided by n minus 3 factorial. We can cancel n factorial. Let us cross multiply. N minus 3 factorial is equal to 42 times n minus 5 factorial. Now, if you compare n minus 3 and n minus 5, n minus 3 is a bigger number. So I can split this bigger number, bigger factorial, as n minus 3 times n minus 4 times n minus 5 factorial is equal to 42 times n minus 5 factorial. Open the brackets and simplify. We will get a quadratic equation. So we get n square minus 7n minus 30 is equal to 0. We can factorize this. N minus 10 and n plus 3. We get two answers. N is equal to 10 and n is equal to minus 3. But n cannot be negative. We know that n should be a positive integer. Therefore, the answer is n is equal to 10. In permutations and combinations lesson, n, r, they all take positive integral values. Now same question, second subdivision, np4 divided by n minus 1 p4 is equal to 5 divided by 3. N is greater than 4. Here also the condition is given. Let us use NPR formula. NPR is n factorial divided by n minus r factorial. Let's make use of this formula. N factorial divided by n minus 4 factorial. This is the numerator. Divided by, denominator is n minus 1 factorial divided by n minus 1 minus 4 factorial, which becomes n minus 5 factorial, equals 5 over 3. Let's write the reciprocal of the denominator. We get n minus 5 factorial divided by n minus 1 factorial is equal to 5 by 3. Now, if you see these two numbers, n factorial and n minus 1 factorial, I can split this n factorial as n times n minus 1 factorial. And compare these two numbers, n minus 4 and n minus 5. The bigger number is n minus 4. So I can separate this, split and write this as n minus 4 times n minus 5 factorial equal to 5 divided by 3. Let us cancel the common terms. Cross multiply. 3 times n is 5n minus 5 fours are 20. So 2n is 20. Therefore, n is equal to 10. Example 13. Find R if 5 times 4PR is equal to 6 times 5PR minus 1. NPR formula is n factorial divided by n minus r factorial. Five times 4 factorial divided by 4 minus r factorial equal to 6 times 5 factorial divided by 5 minus of r minus 1, which makes it plus 1. So 6 minus r factorial. 4 factorial divided by 5 factorial can be written as 5 times 4 factorial. Compare these two numbers, 4 minus r and 6 minus r. The bigger number is 6 minus r. So I can write 6 minus r factorial as 6 minus r. 1 lesser than this is 5 minus r. 1 lesser than this is 4 minus r. Factorial will remain. Five also could be cancelled. Cross multiply. 6 minus r times 5 minus r is equal to 6. Open the brackets. 30 minus 6 minus 5 minus 11r plus r square minus 6 is 0. We get a quadratic equation in R. Let us factorize. R minus 8 and R minus 3. 8 3s are 24. We get two answers. R is equal to 8 or R is equal to 3. But the question has 4PR. And we know that 0 less than or equal to R less than or equal to 4. Therefore, R cannot be 8. The final answer for R is equal to 3. Example 14. Find the number of different 8-letter arrangements that can be made from the letters of the word daughter. This is an important question. In the word daughter, we have 8 different alphabets. And in these 8 alphabets, we have 3 vowels. And the first subdivision is vowels occur together. So together cases we know how to do. We put these vowels together and count these 3 letters as one letter. This is how we do together cases questions. And let us write the remaining alphabets: D, G, H, T and R. So count this as one letter: 1, 2, 3, 4, 5 and 6. We have to arrange 6 alphabets. So considering the vowels A, U, E as one letter, we have to arrange 6 letters. So number of ways to arrange these 6 alphabets is equal to 6p6, which is 6 factorial. 6 factorial is 720. Then the vowels, the 3 vowels should occur together, but they can be arranged among themselves, like A, U, E and A, E, U, etc. So let us count how many arrangements are there. Vowels will be together, but we can arrange the vowels among themselves. Vowels can be arranged among themselves in 3p3, which is 3 factorial ways. 3 factorial is 6 ways. Therefore, total number of ways is equal to 720 times 6. The answer is 4320. Now the second subdivision, all vowels do not occur together. Vowels not together. How to do not together cases? Total number of cases minus together cases. Let us calculate the total number of arrangements. We have 8 alphabets. 8 alphabets can be arranged in 8p8. We have 8 distinct alphabets. Which is 8 factorial. And 8 factorial answer is 40320. Therefore, number of not together cases is equal to total number of cases minus together cases. Total number of cases is 40320 and together cases we got the answer as 4320, the first answer. Therefore, the difference is 36000. Example 15. In how many ways can 4 red, 3 yellow and 2 green discs can be arranged in a row if the discs of the same color are indistinguishable? So we have identical items. We have 4 red, 3 yellow and 2 green identical discs. So number of ways is equal to, for identical items we use this formula, n factorial by p1 factorial into p2 factorial into p3 factorial. Here the total number is, totally we have 4 plus 3 plus 2. 9 discs are there. So 9 factorial divided by 4 red ones are there, 3 yellow ones and 2 green ones. Let us simplify this answer. 4 factorial could be cancelled. We will get 5, 6, 7, 8 and 9 divided by 3 factorial is 2 into 3 and 2 factorial is 2. And the answer is 1260. Example 16. Find the number of arrangements of the letters of the word independence. The first question is find the number of arrangements of the letters of the word. So we have to make use of all the letters. How many letters are there? 12 are there. Now out of these 12 letters, we have N 3 times, E 4 times and D 2 times. So we have identical alphabets. Therefore, number of ways is equal to, we will use n factorial by p1 factorial into p2 factorial into p3 factorial formula. So n here is 12. So 12 factorial divided by, we have 3 n's, 4 e's and 2 d's. Let us simplify this answer. Cancel 4 factorial. 5, 6, 7, 8, 9, 10, 11 and 12 divided by 3 factorial into 2 factorial. Five eights are 40, 7 nines are 63 and 66 and 0. 2520 into 660. The answer is 1663,200. Now first subdivision. In how many of these arrangements do the words start with P? We have to arrange 12 alphabets. The condition given is it should start with the letter P. So we don't have any other choice for the first position. Now the remaining 11 alphabets should be arranged. So 11 factorial divided by, out of these 11 alphabets, we have 3 N's, 4 E's and 2 D's. So total number of ways is equal to, that is starting with the letter P. 11 factorial divided by 3 factorial into 4 factorial into 2 factorial. Cancel 4 factorial. 5, 6, 7, 8, 9, 10 and 11 divided by 3 factorial and 2 factorial. The answer is 4 5s are 20 into 7 into 990. 14 times 99. 6, 8, 3 and 1. And the answer is 138600. Second subdivision. In how many of these arrangements do all the vowels always occur together? So vowels should be together. So put all vowels together. I, E, 4 E's we have. These are the vowels. So put all these vowels as one and I'm writing the remaining alphabets N, D, P, N, D, N, C. So count the number of alphabets. 1, 2, 3, 4, 5, 6, 7, 8. We have to arrange 8 alphabets. Out of these 8 alphabets, we have 3 N's and 2 D's. E's 4 you should not count because we took it as one alphabet. We put all the vowels together and we have counted them as one alphabet. So don't consider 4 E's. So number of ways is equal to 8 factorial divided by 3 factorial into 2 factorial. You have to write the explanation. Considering I, E as one alphabet, we have to arrange 8. And the vowels can be arranged among themselves. So vowels can be arranged among themselves. They will be together, but in 5 are there, 5 factorial by, out of which 4 are identical. So 5 factorial by 4 factorial, which is 5 ways. Therefore, total number of ways is equal to 8 factorial divided by 3 factorial times 2 factorial into 5. Let us simplify this answer. Cancel 3 factorial. 4, 5, 6, 7, 8 into 5 divided by 2. The answer is 20 into 42 into 20. 42 times 400. Third subdivision. In how many of these arrangements do the vowels never occur together? Vowels not together. We know how to do not together cases. That will be total number of cases minus together cases. Total number of cases was our first answer, 1663200, minus together cases was the recent answer which we got, 16800. Subtract and write the answer. It is 0, 0, 4, 6, 4, 6, 1. So the answer is 1646400. Now the last subdivision. In how many of these arrangements do the words begin with I and end with P? So the first letter is I, the last letter is P. Out of 12 alphabets, we have to arrange the remaining 10 alphabets. Out of these 10 alphabets, we have 3 N's, 4 E's and 2 D's. Let us simplify this answer. So cancel 4 factorial divided by 3 factorial is 2 into 3 and 2 factorial is 2. And the answer is 12600.